Everyone. Today we are finishing up the rest of the lesson on the quadratic formula. So you'll have to flip back in your notes to this page, which is where we left off last week, I want to say Wednesday. Okay, and I'm going to take just a quick second and zoom this in a little bit. So I believe we got up through example 2 in all of my classes. It's possible some of you didn't get all the way through example 2. That's okay. Don't worry about that. You've done enough quadratic formula by this point with all of the Newton's formula stuff and everything that you should be good up through example 2. And even example 3, I don't know that I'm going to work all the way through. I just want to take a minute and point out the difference in the wording. So you'll notice example 3 asks you to find the x-intercepts of this quadratic function as opposed to these other ones that gave you equations, meaning it was equal to something, and you were solving. So let's talk about how example 3 is a little different. We talked way back in chapter 3 about x-intercepts and how anytime you're looking for an intercept, you're plugging in a 0 for the opposite variable. So if you're looking for the x-intercepts, that means we want y to equal 0. And that means I'm going to put a 0 in for y right here. So if I put a 0 there, and then write this out as follows, negative 3x squared minus 2x plus 1. Now I need to solve that thing for x. And to do that, I would use none other than the quadratic formula. Now I'm not going to take the time to work through quadratic formula right here because number one, you should have examples worked out up top of quadratic formula. And we're going to do some more quadratic formula in the following examples. But I just wanted to point out that that's really the benefit of the quadratic formula, is it helps you find the x-intercepts, otherwise known as the roots of quadratic functions. Okay, and you saw that when we did Newton's formula, so that probably isn't shocking to you, but I just wanted you to have that written down for your example 3. But I want to go back to the back side of your notes here that talks about simplifying radicals, because today our focus is on using the quadratic formula to get what's called an exact answer. And the problem we run into is, like, for example, if you were to type in square root of 50 on your calculator, you're going to get a decimal that has to be rounded off. It's an irrational decimal, and irrational decimals are not exact. So we have a different way of working with square roots where we don't just type them into our calculator and get ugly decimals. But to use them, we have to simplify the square roots, kind of like we simplify fractions or simplify expressions, things like that. So what this counts on very heavily is you knowing your perfect squares. Okay, so we're going to make a list of them at the top of the page. So when I say perfect squares, I'm talking about like 1 squared is 1, 2 squared is 4, 3 squared is 9, 4 squared is 16, and so on. So there's 5 squared, 6 squared, 7 squared. Let's see, I'm losing track here. 8 squared, 9 squared, 10 squared. And that's probably far enough for now. I can't promise that you'll never need one bigger than that. But you should know those numbers very, very well. And those should kind of jump off the page at you as like, hey, look at me, I'm a perfect square. So when I look at 50, what I want to try to think about is how could I write 50 as 2 factors, so something times something, where one of the 2 somethings is a perfect square off this list. And we want to try to use the biggest perfect square we can find. So as I'm looking down this list for something that divides easily into 50, 25 jumps out at me. Okay, so I'm going to take the square root of 50 and I'm going to write it as square root of 25 times square root of 2. Okay? Hopefully you agree with that. That's a true statement. The square root of 25 times square root of 2 would give me back square root of 50. And then I know what the square root of 25 is. It's 5. And then this, because I can't take a square root of 2, is just going to stay the square root of 2. Okay? And that's simplified. This is considered to be a simplified radical or a simplified square root. So let's try 108. Okay, and I'm looking for something that goes into 108. You may come up with something different than I do, but I do believe 9 goes into 108. So I'm going to write this thing as square root of 9 times square root of something. Oh, and I should know that one, square root of 12. Okay, 9 times 12 is 108. And if you didn't know that off the top of your head, if you didn't know that 9 went into 108, that's okay. You could go in your calculator and start dividing. So you could start doing 108 divided by, well, 1 isn't really going to help you. We're really not going to use 1 that often. But 108 divided by 4, 108 divided by 9, 108 divided by 16. Remember, you're looking for the biggest one. I will tell you that I very intentionally did not pick the biggest one that would work for 108 because I think this is something that happens quite often. And now I want to show you what you can do with it from there. So square root of 9 we're happy with because that's a perfect square. Square root of 12, that's not on our perfect square list, but 12 can be broken down further. So 2 back here we couldn't do anything else with. There were no other perfect squares that would divide into 2 besides boring old 1. But 12 can be made up into another perfect square. Okay? The 12 has a 4 that goes into it. So the 12 can really be square root of 4 times square root of 3. And so now I have a perfect square here and a perfect square here. Okay? And I'm going to cross out this 12 because we turned the 12 into a 4 and a 3. Now I'm left with the 3 down here. There are no other perfect squares that go into 3. So I've gone as far as I can go. And that means I have square root of 9, which is 3, square root of 4, which is 2, and then a square root of 3, which I can't do anything else with. And you'll notice that's multiplication in between there. So I would really turn this into a 6 square root of 3. Okay? So I emphasize to pick the biggest square root that works into one of these numbers just because it saves you from having to do like a second step like this. But worst case scenario, if you pick one that's too small, you just have to do another step. Okay? Just so you can see what it should have looked like if I had done it quote unquote correctly from the beginning. 36 actually divides into 108, but I didn't expect that you necessarily knew that off the top of your head. But if you were trying it on your calculator, that wouldn't be a bad way to go. So I could have taken that 108 and written it as square root of 36 times square root of 3, because 36 times 3 is 108, if you happen to know that. And then square root of 36 becomes a 6. And then square root of 3 just stays square root of 3. So either way, you come out with that same answer. This way, it was easier to come up with a 9 than it was to come up with a 36. But I got to the answer eventually. So how does that all play into the quadratic formula? Well, you remember the quadratic formula has that big square root in it, right? And so now we're going to get to the point where I say, give me an exact solution. Anytime I say exact solution, your square root should end up looking something like this, unless they're perfect squares and they clean up nicely. But we don't want any of those ugly decimal answers that we were getting before. So let's set this up with quadratic formula. So it's negative b plus minus the square root of b squared minus 4 times a times c all over 2 times a. Okay. I do also want to warn you that in a few days, actually it doesn't look like it's until next week, but next week you will have a quiz that has questions like this on it that you will not be able to use a calculator on, like at all. So crunching numbers like this mentally, if that scares you, start practicing it now. So if I was doing this in my head, I would say this is 64. Here, just write this up here. This is 64 minus 4 times 2 times 2, that's really like 4 times 4, which is 16. So that's 64 minus 16. And then if I'm having to do this in my head, I mean, you could write it out off to the side and actually subtract it. But I would go 64 minus 10 takes me to 54. And then take another 6 away. Well, taking away a 4 would take me down to 50. And then taking away another 2 would give me a 48. If you didn't follow me there, that's okay, but maybe try it on your own. Maybe pause the video and see if you could crunch that value and get 48 out of it without a calculator. Okay, so now I'm left with the square root of 48. And at this point, normally we would go ahead and punch that into our calculator and it's going to come out some God awful decimal, okay? We don't want to use that decimal here because we want an exact solution. So we are going to take this square root of 48 and break it up the same way I broke up these up here. So I'm going to try to take that square root of 48 and rewrite it as something times something. And specifically, I want one of those to come from my list of perfect squares up above. So maybe pause the video for a second and see if you can come up with what perfect square goes into 48. And remember, you're shooting for the biggest one you can find. So I will tell you the biggest one you can find is 16. 16 times 3 makes 48. So that's going to be the easiest way to do this one. If you had done it with a 4, you would have gotten like a 4 and a 12. And then the 12 would just have to be broken down again, kind of like we did up here. So that's going to give us that square root of 16 is going to become a 4. And then this is going to just stay a square root of 3. So if I rewrite that whole line now, it says negative 8 plus or minus, and remember now we're using this thing up here, 4 square root of 3 over 4. Okay. And then there's one other thing we can do here. So we're going to simplify this almost like a fraction. And remember that when I have this divided by 4 down here, what that really means is this negative 8 is being divided by 4, and this 4 is being divided by 4. I've got to do it with both. Okay? So negative 8 divided by 4 is negative 2. I'm going to keep my plus or minus in there. And then 4 divided by 4 is 1, which you don't actually need to write down. And the square root of 3 just stays square root of 3. And this right here would be my exact solution. This is what I would want to write down as my exact answer. I could plug that into a calculator and get the decimal version if I wanted it, but because this asks for an exact answer, that's where I'm leaving things. Okay? And that is an example of a problem you should be able to work through beginning to end without touching a calculator. So if you feel like that's going to be difficult for you, like I said, maybe work off to the side and try that whole problem again without touching your calculator. Okay, let's try example 5, and we're going to do the same kind of thing with example 5. So once again, it says exact solutions, so I'm doing quadratic formula here, but I'm not typing the square roots into my calculator. I do have to get this in standard form before I can start, and I think the easiest way to do that is just to move the x squared over. So that means my equation is going to look like this. Negative x squared plus 9x plus 11. Really what I did there is I subtracted the x squared. So now my a value is a negative 1. Okay? So we have x equals negative b plus or minus square root of b squared minus 4 times negative 1 times 11 all over 2 times negative 1. Okay. So when I clean this up, and again, this is one that you probably should be able to do without a calculator. Here's my thought process. 9 squared is 81. Here I have a negative 4 times a negative 1, which is going to give me a positive 4. And then that positive 4 times 11 is 44. So be careful with those negative signs, okay? You can treat this like a negative 4 and this like a negative 1 and say they cancel each other out. But remember, there's still like a hidden plus sign in there. So if you're going to cancel out the negatives, make sure you don't suddenly turn this into multiplication up here. That this would still be addition because you just made this a positive value instead of a negative. Okay, so 81 plus 44. Well, let's see. 80 plus 40 is 120, and the 1 and the 4 make 5, so that really becomes a square root of 125. And then we have it over negative 2. Okay, and then that 125, I'm going to try to rewrite that thing as a square root of something times a square root of something. And remember, I want one of those somethings to come off my perfect square list, which is at the top of your page. You can't see mine, but you should be able to see yours. And I'm hoping that you know that 25 goes into 125. So 25 times 5. Okay. That 25 can be crossed out and just turned into a regular 5, and then your square root of 5 just stays the same, stays a square root of 5. So when I rewrite, I end up with negative 9 plus or minus 5 square root of 5 over negative 2. Now, in the last one, in that last step, we took these and divided them because these both easily divided by that 4. If I'm trying to do 9 over 2 and 5 over 2, those don't divide evenly, so I can just leave my answer like this. If you wanted to make these 0.5s, if you want to make it 4.5 and 2.5 to actually divide, that would be okay because you're not rounding off that decimal. But really, it's 100% acceptable and even encouraged for you to just leave your answer like this. Okay, so that's what you're focused on today, is how to do the quadratic formula, but using this simplified square roots instead of using decimals. Okay, if you look in your homework packet, you have, I think, just 6 problems to do today. Notice I gave you lots of space because I should see every bit of your work written on this paper. In an ideal world, you would not use your calculator here at all. That being said, I do notice that I gave you some with some pretty big numbers. So if you need your calculator to do some of the multiplication and addition in here, that's okay for today, but you're not using your calculator to do the square roots at all, okay? And then again, keep in mind that you will have a quiz where you can't use a calculator at all, so I would try to rely on it very minimally, okay? But when I designed the numbers for this assignment, I wasn't thinking about you not having a calculator. So if you need them for a few, that's okay. Okay, so that's it for homework for tonight. It's just those 6 problems, but I should see every bit of work written out just like I did here in example 4 and example 5, and then we will spend some time going over this in class tomorrow.